Hey, good morning, everybody. Happy Friday. Sorry I'm not at school again. I have to be out until Monday, but I'll be back on Monday. Hopefully that's good news for you. Um, so, a little heads up here that we are going to write a small quiz. 6 questions, 6 marks. Small, non-stressful, don't worry. But a small quiz on Monday. That quiz will include forces of gravity, forces of friction, and some FNet. There might be a spring force in there too. It could have springs. I can't even remember. Let's put that in. Spring/elastics, and then the odd question on some FNet equals MA. At this point, I hope you're not stressing out too much, because if you've been keeping up on your practice, you should feel like you're mostly ready for this. If you've been piddling away your work time without me there, this could come back and bite you. So you're going to want to complete all your homework, get all your practice questions done. That's the best way to get yourself ready for this quiz. We're already halfway done this chapter. Remember, this is not a chapter where you can fake it. If you're not doing that practice, it's going to get you on the chapter test for sure, guys. So please make sure you're doing that homework. If you get stuck on a question and the online solutions aren't helping you, just fire me an email. I'm checking lots every day. I'll check on the weekend. There's my email address there, jheinrich@sd67.bc.ca. And this doesn't go for everybody, but it sounds like some people need this reminder, especially in block 2. But block 3 can hear this as well. Put your phones away right now. So we're watching this video at the start of class. Power your phone down. Put it away for 80 minutes. You don't need it. So get your phone away. Pay attention to the video. Make sure you're writing down the example and working along with it. Ask for the video to be paused if you need. You'll go through another lesson through a video on tension and pulleys today. Make sure you're watching that. And then use your class time efficiently. Don't just pull the phones back out. Please, guys. I really don't want to hear from the TOC that a bunch of people sat there and did nothing. Remember that your behavior when a TOC is there reflects on me as a teacher. And so if you're not doing anything, it actually looks really bad on me. It looks like I'm just sort of letting class be a free-for-all. So please act for the TOC the same way that you would act for me. And we have tons of fun together. I love teaching you guys. Let's make it the same regardless of who's standing at the front of the classroom, please. Anyways, and that doesn't include all of you. So if you haven't been on your phone and you've been working hard, please ignore that message. But a few people maybe getting a little bit too comfortable and needed just a little reminder to buckle down. Anywho, let's try out another practice question, and then I'll turn you loose on the actual lesson for the day. So one more Newton's laws before you move into something a little bit different for today's lesson. We've got a 3.6 kilogram bowling ball rolled down a long hallway with an initial velocity of 4.2 meters per second. We've got a force of friction of negative 1.9 newtons. It's negative just because it's pushing backwards. We want to know how long the ball will roll before it stops. In this case, there's definitely going to be multiple forces acting on this ball. So I would draw a free body diagram. Go back to our trusty FBDs. So here's our ball rolling down the hallway. Remember, I'm not going to put 4.2 meters per second in there. I'm only going to put forces in my picture. So we have gravity working downwards. And if you want, you can go find that. You've got the mass. You know that the strength of gravity on Earth is 9.8. So if we pull up the calculator, (35.28), N for newtons. So there's your force of gravity pulling down. The ball is not accelerating into the center of the earth or floating into the sky because the floor is pushing back. And it's simply counteracting the gravitational force. So those two mathematically are going to wipe each other out when we go to do F net. Now, what you really have to avoid doing in this case, and I see a lot of students get stuck, is they like to draw this in. They put the 4.2 in there like it's a force. But remember, there is no 4.2 newtons of force. That's 4.2 meters per second. So that does not go in my diagram. And if you think about this ball as it's just rolling down the hallway, I know it's moving forwards, but once it's out of the person's hand, whoever bowled it, there is actually no forwards force acting on it. That forwards force came from their hand, but it stopped the moment it left their hand, and now it's just rolling freely down the hallway. So if there's no forwards force, there's certainly going to be a friction force fighting backwards. And we're given that number. It's negative 1.9. And for newtons. And it turns out that's it. That's all there is to our diagram. So this question, this ball rolling down the hallway, is actually a lot like the skidding car example we saw a few days ago. You should have seen 2, 3, maybe even 4 of those if you've been doing your practice. And if you have no idea what I'm talking about, you need to do your practice. So that's all there is to the picture, the diagram. So if we jump into using that FBD to figure out F net equals MA, then the net force, the 35/2/8 cancel out. The net force is simply this negative 1.9 newtons of friction force. That is F net. It's the force of friction. Not always, but in this case it is. So that's equal to 3.6 times A. And in this case, we do want the acceleration to be negative because that ball is going to slow down. So I'm going to leave that negative sign in there. Negative 1.9 over 3.6 is negative 0.5278. 5278 meters per second squared. Now that is, again, the chapter 5 portion of this question. Now we're back to familiar territory. We actually want to know how far the ball is going to roll before it comes to a stop. So that means we're into VIFDAT. And I'll finish this question off, although I feel like I could just stop the video now and say, hey guys, go finish this. You should be able to do this backwards, forwards, eyes closed, eyes open, anytime. Well, I'm kind of kidding about that stuff, but you get what I mean. Initial velocity, 4.2 meters per second. Ball rolls to a stop. How far does it go? We've got our acceleration. We just found it. And no stopwatch. So we hit the formula sheet. Vf squared equals Vi squared plus 2AD. 0 equals 4.2 squared plus 2. Running out of space. Oh, here, let me pause this and move some stuff over. There we go. 2 times A. Oops. 5, 2, 7, 8 times D. So let's take that number, double it. 1.05555. That's going to come out negative. I'm going to have to shuffle it over to the other side. I'm just going to leave that as 4.2 squared for a moment. 1.0556D. Let's add that 1.0556 to the other side. Equals 4.2 squared. And divide both sides by 1.05556. D equals 4.2 squared divided by 1.0. There we go. 16.7 M for meters. So a good solid F net equals MA question. Really testing, do you know the different forces acting on the object? Can you draw a free body diagram? And then you're off into F net equals MA and some kinematics to finish it off. All right, so there's a little more practice. Don't forget, we'll do a quiz Monday. I'm happy to go over a few things with you before we write the quiz. We don't have to throw it at you very first thing in the class, but it's not going to be, hey, let's do all the homework questions together because I slacked off for 3 days while the TOC was there. So again, please use your time wisely today. Pay attention during the lesson. Get your homework done. Go back, brush up on boxes 1 through, 5? I guess was all the F net equals MA. Today's lesson on tension and pulleys will not be on the quiz. It'll just be the stuff up till, I guess, last day. And email me if you have any questions. We'll see you guys on Monday. Have a fantastic weekend. Work hard today. Enjoy the sun. See you in a few days.